Hello and welcome to the second JointCAM tutorial video where we're going to start going over the different types of joints and how to cut them and how do we set the parameters and get all the information JointCAM needs to start cutting your joints. As we mentioned before, when you start JointCAM you're going to be on the start page. Start page lets you choose any of the available joints to start with. You can click on the buttons, you can click on the tabs at the top and select the joint by the tab. You can load an existing project which will take you to the tab that project was saved in. You can exit the screen, exit JointCAM from here. You can do a few different things. You can go to the configuration as we shown before. You can go back to the start. We're going to start with half-blind dovetails, equally spaced. That's what this video is going to cover. So we'll just click on that right now. JointCAM will go to the half-blind equal spaced tab. Here's where we set up our joint, export our G-code, save the files, save the project if we want. This is where we make our joints. First thing we're going to show, we're going to talk about the tools and go to this take a look at the tool table. JointCAM has a tool table that lets you save all your tool information to be recalled really easily later on. So if you have a large library of tools, you only need to enter them once, and then they're always available to select them in JointCAM. For half-blind dovetails, you only need one tool to cut them, the dovetail bit. So we're going to select tool and take a look at the tool table. Here we have our tool table's got quite a few tools in it, about 7 or 8 tools here. We've got a few straight bits and a few dovetail bits. It's a little sluggish looking because of the recording software. Normally it's pretty smooth here. To select a tool, we can pick a tool from our list. Click select tool down here at the right, and JointCAM will fill up all the tool information from that tool. We're going to go back to the tool table for a moment and look at how the tool table works. We can add tools, we can edit tools, we can remove tools from the tool table. To add a tool, we decide, first thing we do is we select the type of tool, whether it's a straight bit, which is going to be used for roughing for a half-blind dovetail or other dovetail joints, or the dovetail bit. JointCAM has a little safety check because we started out choosing a dovetail bit. I hope I got off track for a moment here. We're going to go back to adding a tool. Let's forget that for a minute. First you're going to do is select your dovetail bit or straight bit. Well, let's go back what I was just about to mention. If you tried to select a straight bit in here and select tool, you're going to get an error because it's the wrong type of tool. So we're going to exit the tool table. When you select a tool for a dovetail bit, JointCAM will only let you select a dovetail bit. And same thing when you go to select a roughing bit, which is a straight bit, you can only select a straight bit. Trying to select a dovetail bit for a straight bit is going to give you an error. So we're going to exit back out, come back to the select tool. So to add a tool into the tool table, first we select our tool, choose a tool number. I believe you can use any number up to 999, so you can keep 1,000 tools in here. Put your length, your feed rate, your depth per pass for a straight bit. We're going to do a dovetail bit. Depth per pass is not an option for dovetail bits because they must be cut in one pass full depth, or you'll have a lot of stair steps in your joints, which won't look very good. You put your diameter, your tool angle, and your RPM. You can add a note. We already have a test bit up here that we did the last time we were trying out the video on a sample video. A note is the note's only used in the tool table just to give you a description of what the bit is. Here you see I have tool numbers, manufacturers, and part numbers for these bits. So if I want to say, if I create some G-code with tool number 11, I can come in here and look at tool number 11 is an Eagle America 134-10002, which they no longer manufacture, but I have a couple of them. So basically, once you enter your information, we've got some information here. We're going to just do a test. We click Save Tool, and that tool is added to the tool table. Whenever you add a tool to the tool table, edit the tool table, delete a tool, you're going to want to save the tool table by clicking the button Save Tool Table. If you don't save it, JointCAM will give you a warning when you try to exit the tool table that the tool table has not been saved. And if you don't save it, you'll lose that tool information. To edit a tool, select it in the list above by highlighting the line and hit the Edit Tool button. And as you see, when you edit a tool, it's removed from the tool table and brought into the to the edit area. So you can make a change. You can change the tool number. You can change anything you want. You can change the angle, and then save the tool, and it's placed back in the table. And we can save the tool table. To remove a tool, just highlight the line and delete tool. We'll delete this one because that was also a test tool. And we'll save the tool table. We still have to select our bit, so we're going to select the standard number 10, tool number 10, half-inch 14-degree bit. And we're going to select tool, and number 10 tool will be loaded into the file, into the parameters. And for a roughing bit, we're going to pick a 3/16 straight, and we'll select that. The roughing bit doesn't have anything to do with the preview or the calculation. It does check, JointCAM does check to make sure the tool is not too large, so it won't make any gouges. But it doesn't have anything to do with the joint. Okay, so we were going over the one-pass dovetails. JointCAM also lets you do a multi-pass dovetail, which can give you a lot bigger variety of joints. They're still equally spaced, but you can have pins and tails different widths. So here we have a tail width of 1 and a pin width of a half. The tails are the orange boards, which are not shown in the preview, but it's the void, it's the empty space. We're at half tail width for the start distance, so you have a ½ inch and then a 1-inch tail and a ½ inch pin and a 1-inch tail and so on. You can also set pins equals tails. When that happens, when that box is checked, the pin width is set to the tail width, and it's disabled, so you can't change it. So then the pins, everything is 1 inch, 1, 1, 1, 1, 1, ½ inch start distance. We can center the joint. We can change the start distance if we wanted to. Typically, you're going to use probably half tail width or centered for the start distance most of the time, but there's different. You might have to fine tune to fit on a certain size width of stock. So there's a lot of options you can do to make your joint look how you want it to look. As you just may have noticed, I had there's a full tails only box. Let's change this to something else and see what we end up with here. That's not what we want. We don't want it. Say you're not centered, and say you want we want a bigger tail here, and we want a smaller pin width. Certain configurations, you're going to end up with a partial tail. If you don't want a partial tail, there's a full tails only checkbox. By checking the box, recalculating, JointCAM won't cut a partial tail. So depending on what you're looking for, you have another option to configure your dovetails here. The next item, number of tails, is a read-only display, and it shows the number of tails that you're going to end up with in your board. Partial tails count as a tail, so right here we have 3 tails, 1, 2, 3. If you check full tails only and we do it again, now you see there's 2 tails. 2 tails are displayed. The pin tail offset we talked about earlier. We'll have to go back to pins equals tails for a second. If you're machining both joints at the same time, you need to offset the pin board by an offset amount. The offset amount is the pin tail offset. Typically, you would use some type of spacer probably on your fixture to space that board over so the joints can be cut at the same time. As you noticed, you can't cut pins and tail boards together if your pins and tails are not the same size. When we change, that shouldn't be disabled, but it is. When we change that, we are disabled. when pins equals tails is turned off, the pin and tail board option is disabled. It probably, if the two joints are the same size, it probably should be enabled, but you can just turn off multipass. Or actually, we can do about it a different way. You just use pins equals tails, and then you can get the option back. That was a little bit confusing, probably. But that's basically that's your dovetail types: multipass, one pass, and a few other options to cut. Basically, an infinite amount of joints. Also note that you can vary the depth of cut to just about anything you want, as long as it's within the length of your bit, which down here we have a 1/2 inch. You can cut a full 1/2 inch. You can cut 1/8 of an inch. So we can use thin stock, thick stock. One bit can cut an infinite amount of joints, compared to, say, a manual dovetail jig with a handheld router, where you're limited to the depth is limited based on the spacing of the joints, based on the spacing of the jig. With JointCAM, there is no limit. Okay, next item we have is a scoring pass. A scoring pass is basically to eliminate or minimize chipping on the tail board. And what it does is it cuts a light pass along the front of the board before it starts to cut the dovetails. The manual has a small illustration showing what a scoring pass does. And what it does is it comes across the screen, across the front of the board before it starts to cut the joints, and this cleans that out so that when you do cut the joints, when the bit's exiting the board, it's not going to chip it. We have a little issue with our video card driver. The screen doesn't always refresh on us. Okay, so the scoring pass, we can enable it, we can disable it. Typically, you're probably going to leave it enabled. Scoring depth, there's a maximum depth based on the joint. You don't want to gouge the front of these tails with the scoring pass. So JointCAM will limit you to whatever the max depth is. You don't really need a lot. It can be a very small amount. You just want to score it to prevent the wood from tearing out. If you try to set it too large, when you calculate, JointCAM will tell you that it's too large, and it'll set it to the maximum allowable amount, which you can see is, well, it sets it in the software. It doesn't update the screen. We'll make a note of that, and we'll get that fixed at a later time, so that the scoring depth is updated when it is calculated. Clearance is the fit of the is an adjustment to it. Is a setting to adjust the fit of the joints. The clearance is actually the space between the pins and the tail on the side walls. And the manual has an illustration of the clearance. It's a little bit hard to see here, but it's the space here that you want to, you can increase the clearance, you can decrease the clearance. A negative number makes the joint tighter. A negative clearance, a positive number, loosens the joint up. Note that dovetails need to be very, very precise to have a good fit. There's very little margin for error. So a very, very small clearance values can make a big difference. As you see, I have -0.02 of an inch. Typically, if you have if your bit is accurately sized, a clearance of 0 will give a decent fit, maybe a little bit loose. A clearance of -0.02 may not even go together. It might be too tight. To adjust the clearance, what JointCAM does is increase or decrease the depth of cut by a small amount. It uses trigonometry to calculate that amount based on the actual clearance that you request. But it's actually the amount that the depth that will change to achieve 0.02 of clearance will actually be less than the 0.02 of an inch. And next option, use roughing tool. For one pass joints, what JointCAM does for a roughing pass is very basic, and it uses the same tool path as the dovetail bit. So it will come into the pins, it'll come in, travel around. We'll look at the illustration here. It'll come around the tail, make the socket, cut around the tail, make the socket with the same bit. So you want to use the largest bit as possible for one pass. I need to revisit this. At some point we'll update the roughing code to allow for maybe larger tool. If you had a very large tool, so you could do some more of a multi-pass type of roughing. With the multi-pass, we do a multi-pass roughing because you can have large joints, and you may say you want to use a 1/4 inch bit to rough this out. You're going to have to make a lot of passes. So we have a roughing step over setting, which is a percentage of the tool diameter. So if we're using a 1/4 inch bit to rough most of this material out, say you had a bit that, whether you had a bit that size or you just want to remove it to lighten the load on your machine, it's going to step over by a maximum of 80% of the diameter. But note the first pass is always going to be full depth because there's no way around that. Typically your actual step over is going to be smaller based on the type of tool path required. You might have an extra pass needed to have, as the tool has to enter and exit a certain number of times. An additional pass is possibly added, and the step over might be slightly less than the specified. So think of the step over as a maximum number. Next item. Roughing allowance. Roughing allowance is with a multi-pass dovetail again. Is a small amount of material left from the where the socket is to the roughing cutout. The roughing, say you have a roughing allowance of 0.015, the tool will leave 0.015 material here at each corner of the socket when it's cutting it out with the roughing tool. The roughing depth allowance is the depth that the roughing tool stops short of the floor of the socket. So with 0.05, the tool will be 0.015 above the bottom of the socket, and it will leave that material for the finish tool, for the dovetail bit to remove. And then the last option here, the tail socket overcut. When you're cutting dovetails, you typically want to cut the sockets a little bit deeper than the thickness of the board so that you're not too short, just to make sure there's a little bit better fit. And you're going to want to usually trim the edge off, so if there's any chipping you can sand off or route off the excess. So this is what overcut looks like. There's a little illustration in the manual. We set typically you're going to want, I like to use about 1/32 of an inch, maybe a little less. You don't usually need much more. And then what it does is it'll cut the sockets a little bit deeper than the tails, so the tails can insert past the sockets, and then we'll trim that up later and clean it up. So if you have an overcut of 0.03 inches and you're making a box, your total overcut's going to be 0.06, so you're going to want to make your drawer fronts and backs double the overcut longer, because that material is going to be removed later. So just keep that in mind when you're calculating your parts for your box size. Another use for the overcut is some controls in a constant velocity mode like Mach 3. As you're moving in to cut the socket and the tool changes direction and comes back out, if your machine has a low acceleration, it may not go all the way into the joint. It might start to turn around before it gets to the end of the tool path. So by increasing the overcut, you can adjust how far in. If your machine does not cut your socket deep enough, you can add some overcut to get it to cut to the depth you want. With all these joints, you're going to need to make a few sample cuts to make sure everything's working as you want it to before you commit to your actual finished joints. Especially if you're using expensive woods, you want to use some scrap wood to do some test cutting first and make sure everything's fit, and then before you commit to the actual finished joints. So when as you've noticed, we hit this calculate preview quite a bit to look at different joints so far. When you may have noticed when we first started, the write G code was disabled and grayed out. You can't write G code without calculating. However, whenever you do write G code, JointCAM will recalculate the joint. So just as a little reminder, it's possible to change any of these settings up here and write the G code, and the G code will not be what the preview is, because the preview is not updated when you write G code, but the calculations are updated. So if you were to change the depth of cut to say 0.25 and write your G code, you're not going to get the joint that you see. You're going to get a joint with a depth of 0.25. So be sure to always calculate prior to writing your G code file. Let's see, so we have our tools selected. We went over the tools, we went over the calculate, preview, everything on the screen. The last thing is machining options, which we touched on a little bit as we were going through the screen here. Machining options let you tell JointCAM which joints you want to cut. You can cut both pins and tails, both lefts and rights, all in one G code file. You can cut left joints only, pins and tails, pins, tails only. Take your pick. Right joints, pins, pins and tails are all. A little note about the pin tail offset that we talked about earlier. The tail boards are always mounted against the fence, which would be one side would be 0 and the other side would be the machine width that we talked about in the first video. When you cut the two joints together, the pin boards use an offset, which is the pin tail offset. However, if you cut the pin boards by themselves, we do not use the pin tail offset. The edge of the pin board is at 0, and depending on your axis that you're using, one edge will be at 0, the other edge will be at the machine width. And the reason for that is if you don't want to cut them at the same time, then there's no real need to try to make a spacer that's 437 thousandths of an inch, when we can just put them against our fence and mount them at 0. And if we go back and look, if we can find it real quick, at our where's it at? Here we go. For our sample machine illustration, when we mount our vertical fences and our horizontal fence, they're going to be in the same plane. So if this is a y-axis machine, or a machine along the y-axis, the two fences on the right are going to be your y0 position. And when you use a spacer, if you're cutting the pins and tails together with a spacer, we have a little illustration of that as well, somewhere down here. Here's what's going to look like if we cut our pins and tails together. Here's where, this is for a y-axis dovetail. Here's where our origin is. Our origin is at the edge of the fence and the back of the vertical mounting surface of the machine. This is a top view. So when our pin tail offset spacer is shown here, notice that we keep the fence. There's a note in the manual. Mount the horizontal fence about 2 times the tool diameter back from the vertical fence. The reason is the roughing tool will plunge down into this gray area here behind the tail board. In the future, we'll update that to start out in front, so we don't plunge into anything ever. But for now, it will plunge in behind. If you start with a dovetail bit, it will start out in front and move back, and then it'll work its way back out. But if we're going to cut pin boards only, we're going to eliminate this spacer, and we're going to mount the pin board right against the horizontal fence, which would be at Y0 in this illustration. It's just a simpler setup and easier to do. And again, we have our refresh issue here. Okay, so that's been our machining options. We can cut our boards or joints in a lot of different ways, depending on how you want how many joints you have to cut, how your machine is set up. You can configure it how you want it to do it. If you want to save these settings as a default, all you have to do is click the Save Settings button. Each tab, each type of joint has its own Save Settings button, which only saves the settings for that particular tab. So for the half blind equal, we can configure our machine. Say we want our machine to do this type of joint, both pins and tails, both left and right at the same time. When we save our settings, that'll be the default for this type of joint next time you start JointCAM. And the tool will be, all the information on the screen will be the default settings if you use the Save Settings button. If you don't use the Save Settings button, there is a default there's a default settings that come with JointCAM, and those will be used. There is no way to restore the defaults once you hit the Save Settings. So your save settings will become the defaults. And a little note for if you're a metric user, the installation should have an option for both inch, imperial, and metric default files. Hopefully we have that set up before we release it. So you're going to want to make sure all the parameters in JointCAM, whether in the configuration or the joint pages, make sure they're all in the same type of units. Do not mix units or you will probably get some errors. So make sure if you're using metric stock sizes, make sure all your values are in metric. Make sure your tools are in metric sizes. If you have an inch tool, make sure you enter the sizes in millimeters. And do not round off tool information, especially with dovetail bits, because the margin of error is very, very, very small with the dovetail bit. They need to be very precise. The smallest amount of error will show up in your joints. So do not round off joints, or do not round off dimensions when you're entering, and say, an inch bit in millimeters, or the other way around. So we do have a few other options here. We can, once we get our joint exactly how we want it, we can save that joint and call it up at a later time by using the Save Project button. Save Project button opens a Save File dialog. It opens it in our default project folder that we specified on the configuration page. And we can type a name. Let me go back. JointCAM uses a joint extension. They're just text files, simple text files. I don't recommend opening them and editing them, as they can cause some problem when you reload them. But you can open the files and take a look at them, and all they are is basically all the information you see on the screen in a simple text file, one line at a time. We're not going to save this, but we're just a sample to show you. And as I think we mentioned earlier, you can load the project, and it'll take you to the specific project page that it belongs on. You can while you're in JointCAM, you can create samples of all the different joints, and they'll stay in effect until you close and restart JointCAM. And it looks like now we're ready to write our G-code. And when we want to write G-code, there's one other thing we can talk about. We have roughing enabled, and we talked earlier in the previous video about separate rough and finish code. If separate rough and finish code is checked, when we write the G-code, it's only going to write roughing code for the roughing tool. If we want to do a tool change and have both the roughing and finish tool in the same file, we do not want this box checked. If you're a ShopBot user, remember we don't support tool changes, so ShopBot by default will act like the separate rough finish code is checked. And in fact, when you select ShopBot, it does check that box. So when you're going to do roughing, just be sure that you know how the separate rough finish code option is selected. If you just want finish code, just disable the roughing and write G-code file. So if you're going to write separate code, you're going to make sure the roughing is checked. You're going to write your G-code file, which would be your roughing G-code. And we're going to go back because we changed our extension to ShopBot. And then we're going to uncheck and write our finish code. Or if you're doing, I use my 2010 screen set, which automatically measures tools, and tool changes are simple, so I write everything in one file. So if I use my roughing tool, I'll get a G-code file with roughing and finish passes in one file. And we'll write a G code. We'll do a little test. And sure, we'll replace it. And we'll open up Mach 3 and we'll take a look at the toolpath. And here we go. And we'll open the file. And somehow we ended up with Mach 3 in the wrong configuration. And we'll fix that. And we'll refresh. And that looks a little bit better. And real quick, we're going to go back into our configuration. And that should have been checked. And we'll save our settings. And we're going to come back here. We'll go back to Mach 3 and we'll take a look. And here you see our first rapid height that we have set rather high to clear any clamps. Actually, let me take a look at something. Actually, that might not be the first rapid height. And we'll go back to Mach 3 for a second. Actually, that I believe that's the park position in my M883 macro. And we can take a quick look, but the first rapid height is actually this first move right here. So in Mach 3 or in JointCAM we had tool and material comments enabled, which is what you see right here on the screen. You have your left and right pins and tails, which is what we're cutting. You have your stock width, your thickness, your tool information. That's your stock and material comments from JointCAM. And in JointCAM you can see the roughing and the finishing tool. And with a single pass joint, the tool paths are the same. You can also see the scoring pass. And that's pretty much what your half-blind dovetail toolpaths look like. So we're going to close Mach 3 here. And that pretty much wraps up this half-blind equal tutorial. I'm sure that I left a lot of questions open. And feel free to look through the manual and hopefully get your questions answered, or feel free to contact me for any help you might need to get going on this. And we'll get back to the next video shortly. Thank you.